I'd like to thank the organizers for inviting me to give a talk. And I'm going to try and bring a little bit of lighthearted. I have a commercial NMR lab where I do NMR work for anybody who'll send me samples, basically. And I do QNMR all day long. It's kind of funny that everybody thinks that it's a new thing, and all the things that are going on with USP and valid NMR that is, is kind of looked at as something new. But I think Joe Ray and people like that, and even myself would say, it's been going on since the 1960s and 1970s. Here's a picture of my lab. I've got 20-year-old mercury systems doing liquid state NMR. On this magnet, I've got an Inova also hooked up for solids. So I kind of do the shimming through the mercury and then do experiments from the Inova. I have boxes and boxes of spare parts that I buy on eBay. This system was bought on eBay. That system was bought on eBay. I've actually been quite lucky supporting myself as a private individual. It's kind of a necessity when you look at what the cost of new equipment is and service contracts that go along with them when you get them. So I've decided to start having an art wall of all the circuits that I had sitting in big boxes, and people kind of get a kick of looking at them. And we have a little R2-D2 that's now out of service that becomes a Christmas tree or some kind of Thanksgiving decorated item at different times of year. Here's a couple of my assistants, Dr. Howlington III and Dr. Ellie McBarkington. They come in and do a little bit of work for me every now and then. And basically what I wanted to discuss was, as an independent lab, it's becoming more and more obvious that I have to start worrying about ISO 17025 certification. There are so many small companies out there working under FDA regulations that it's a big requirement for them to be getting testing that they can't provide for themselves in-house if they outsource it. They need to be going to ISO 17025 labs, certified labs. And for NMR, it's particularly a huge problem because one of the major stipulations of ISO 17025 is that you do proficiency testing and interlaboratory comparisons of test methods that you're performing. And in the NMR world, none of that really exists. So there are a few platforms I've been kind of getting involved in and hoping that they will go somewhere in helping with this situation. One of them is the many QNMR summits that are going on. They're held by USP. Guido Paoli at the University of Chicago is really involved in it quite heavily. Spectral Service get involved in it a little bit over in Europe. And they're doing a lot of good work kind of talking about QNMR. Nothing ever seems to actually happen with respect to them accepting monographs based on NMR or including an NMR component to monographs that already exist, where it's heavily dominated by HPLC, where purity assessments and identification by NMR would be very easy to do, even with benchtop NMRs when you're talking about some small molecules, APIs and excipients and things like that. But nothing's really happening. There's a lot of talk going on. They are trying to do some things. And, what I would hope is that eventually they would kind of move towards, rather than providing standards, which you don't really need by NMR once you've run the spectrum once and assigned it. So you don't need it for like a elution time on a HPLC. You could just run the standard once, but they could then become where they miss out on selling standards to NMR spectroscopists. They would be able to set up a business selling periodic proficiency test standards that would then allow us to have interlaboratory comparisons and kind of open the door to ISO certification for NMR methodologies. Another group that is working in this area is the Valid NMR group, and they're currently working under the auspices of PANIC. And you know, they're there as a support group, providing a forum for NMR method validation in general, GLP, GMP, ISO 17025. And again, you know, this is me being selfish, but I would hope that in the future they would maintain databases of standard spectra for ID and assignment, and then also provide periodic proficiency test standards where you can't get USB or some of the other organizations that do provide a few proficiency test standards might not want to get into because the test might be too niche or whatever. So if you go online and you look at NMR standard methods that are out there, I think there's 2 or 3 that are actually QNMR methods. Most of them are very general. There's like hydrogen content methods. There is a krill oil monograph in USP that is a quantitative one, and also a heparin monograph, but they seem to be about the only ones. There's a poloxamine monograph as well. So, but that's not really a QNMR. That's like a ratio of ethylene oxide, propylene oxide calculation. So you don't really need standards for that, and the results kind of stand on their own. And that's how it goes with all of these tests. You know, there's even tests for time domain NMRs. But for everything on the page here, there are very, very few standard materials that you can buy, so that if you're just getting into doing this test, you know, you get a result and you have no idea, you know, in your isolated world, if you're on the money or not. You just do best practices and hope that the results you give people are good. So for me, so few standards being out there for NMR, there's no mechanism to create samples for NMR methods if they're developed. There is no mechanism for proficiency testing unless a group of laboratories get together, which sometimes they do in Europe. There's a lot of Italian industry papers on different round robin testings that went on over in Europe. But again, you never hear about them. You kind of get invited to be involved, and you know, some of the things I would have liked to have been involved in, I found out about them, you know, months and years after they actually happened. So some of the things that are happening to enable QNMR in the real world is that there are now CRM materials, certified reference materials, that are traceable to NIST. Aldrich is selling them, and so I go through hundreds and hundreds of grams of these every year. So they will provide you a nice certificate of analysis. You choose your standard based on your solvent and overlap with your spectrum of the sample that you're looking at, you know, choosing a standard that's got a peak that's out of the way of the material you're looking at. So that's a step in the right direction. Sigma Aldrich also started providing a dimethyl sulfone sample that is basically it's not a CRM, but it's a proficiency testing sample where you basically log in and register. They deliver that that DMS sample to you. It might be 90.15, 90.23. They're messing around with the purity of it over time. I think they're doing one kind of change every year or every 6 months. You open up a study with them. At your lab, you analyze the sample, you report your results back to them digitally. They do some data processing and do some calculations and figure out your reproducibility and repeatability, et cetera, based on how you compare with the actual value. And then you get an evaluation report back, which is a great way of saying, in general, with QNMR, I have a proficiency test that that works in general. The issue will be when labs are sending you very specific things, and you know, it's not necessarily a tiny small molecule. It might be a larger molecule with lots of labile protons, and so it might not. I really don't think that this is going to always be a way of showing that you are proficient at QNMR just because you look at this one kind of isolated sample. So it's, you know, it's produced by them under the ISO 17034 accreditations for producing CRMs. So again, that's a good start. Eurofins also for the people that have bought Brooker food screeners, where you look at white wine, juice, honey, coffee, spices. There's a lot of profiling going on. The issue with that profiling is it's kind of in-house at Brooker, and the databases are black boxes that you have to pay for access to. And so, you know, for somebody like myself, it's not really useful, but they do have samples that they send out of wines, honeys, where you can kind of bring them into your own house. I've got 300 megahertz NMR systems. Everything that the food screener does is based on 400 megahertz. So I can't directly compare my results to through a Brooker database situation, but I can at least get a report back from Eurofins through Freddie Thomas, who kindly gave me this information. You can get samples, send your results back, and they'll tell you how you're doing compared to people that have honey screeners. So this is another way in some kind of commodity chemistry areas where you could get some good feedback as to how you're doing with your targeted analysis and things like that. And so that was Freddie Thomas that provided that information through Eurofins. And so then I was going to just go through a whole bunch of small caveats of pretty much everything I do almost every day. I get lots of samples from all over the place, and which again is going to make it difficult for ISO 17025 because you kind of have to have a test method for every material you're looking at, and it becomes unwieldy very, very quickly. So for example, I got this sample from Texas. It's a male enhancement Viagra type dietary supplement that works very well, according to the guy that sent me the sample. So I didn't want to get into how he knew it worked very well. The ingredients are oyster, barberry, dextrose, kind of botanical type of things. And I'm a true believer in that most dietary supplements just create expensive pee. So, you know, definitely the things on that list are not going to do the job that this product is doing. And so what we did was we just extracted it with D2O and acetonitrile just to see what would pull out of the general matrix and see what we got. And you know, when you're looking at a botanical, you might expect 300 megahertz proton NMR spectra like these, where you've got just kind of big blobs of sugars and amino acids and proteins and things like that just popping out of the matrix. When you actually looked at that sample, you got this spectrum, very, very, very specific. I happen to have in the Q NMR world, I've kind of been giving a lot of talks at these Q summits on where benchtop NMR fits into that world, because I've had a lot of exposure to the benchtop NMR systems over the years. And so this was a 60 megahertz system that we also had in the lab at the time. And you can see, again, it's very specific. You've got doublet of doublets going on and all kinds of things. And so when you finally do the work, you find out that it's basically a sildenafil analog. So it's a Viagra analog. And we did a QNMR on it at 60 megahertz with maleic acid in solution, looking at some of these aromatic protons here. And it comes out it's 10.84% sulfo-aldenafil, which is a variant on Viagra that is, you know, maybe liver toxic, maybe kidney toxic. Nobody's, you know, it isn't, you know, in the normal suite of ED pills that you get. So, you know, basically these chemistries are not toxicologically screened as they are by the pharmaceutical companies. There isn't a word on the bottle that they're there. So for people that take alpha blockers, you know, you could die from taking these if you did. And then at 300 megahertz, they came out 10.69 ppm. And so one of the other reasons I've been involved in trying to get involved in the QNMR world is to try and pull it away from, and that's why I said QNMR for the real world. It's very, very dominated by metrology. And people are always worried about, well, you know, should I be integrating, you know, the carbon-13 satellites with, you know, with a lot of baseline. So you have to have a very pure spectrum to be doing a good job of the integrations. And so I tend to never look at the satellites, because to me, if this spectrum started to get busy, there's no guarantee that some of the peaks of interest that are going to not be overlapped with other peaks. The spinning sideband, I mean, the carbon satellites probably are going to be overlapped, so you're not going to be able to quantify them. So I would rather lose that 1% of kind of accuracy of your integral from not getting the carbon 13 satellites. I do it for all the peaks across the board, so it's not a full 1% of an error that I'm introducing to the situation, but at least I can start pulling information out of the forest that you're sometimes looking at. And so basically, the fact that these, and so, you know, people really worry about a couple of decimal places of accuracy on their results. And they, you know, say you have to use a microbalance and be at, you know, a thousandth of a milligram when you're weighing these samples out. And in general, when you're looking at commodity samples or you're looking at these kind of samples, the person who's interested in this doesn't really care if it's 10.69 weight percent or if it's 10.5 weight percent. There's still a ton of a non-disclosed pharmaceutical drug in this herbal supplement. And so there's times to be worried about the number of decimal places in your purity analysis, and there's a time when, you know, being within a couple of tenths in this situation is fine. And that's across the board most of the time. So when we started finding this was maybe 5 or 6 years ago. I started working with the USP, and they provided me with a whole bunch of standards and some samples that they were getting from abroad. And it turns out that, you know, on the internet, there's lots of herbal supplements where it might as well just be sawdust that's listed here with this is actually tadalafil, which is, I think it's Cialis. You know, it's sawdust with pharmaceutical drug attached. It doesn't matter if these are actually present or not. So, you know, we developed a database of 300 megahertz data on all the different PDE5 inhibitors that are out there. We did it at 43 megahertz, 60 megahertz, 80 megahertz as well. And you can totally do a lot of this work on a benchtop NMR. And I think with small molecules, I think benchtop NMR might be a good place to be starting talking to USP about purity of API and things like that. Because if the molecules are small enough and they're not too busy, you can get good numbers from the benchtop NMRs, and it would be more available to organizations that might be analyzing these things out there in the world who don't want to buy 400 megahertz NMRs and have chemists that are assigned to it as well on top of that. So some of the other things we're doing, the first speaker today talked about a strong hydrogen bonding situation in one of his natural products. And we were doing a lot of work on hops for a little while for some local hop growers here in New York. Basically, we were spending all our time in the 12 to 0 ppm region, looking at, you know, different peaks that we thought were associated with some of the, you know, the isoprene type things that these molecules are made of. And we're mucking around in there, and it's very busy, and, you know, there's a lot of things going on. We never actually expanded out to 19, 18, 19, 20 ppm. To be honest, I don't think I've ever seen many labile protons that are out that far. And so when we zoomed in, so we were in here trying to figure out all this stuff in here, and you could see some terpenes as well as the alpha acids and the beta acids that brewers are interested in because they bring bitterness or other things to the IPAs they're brewing. These terpenes bring a lot of aspects of taste and aroma to the beers also. So we are quantifying humulines, myrcenes, and then when you go out to that super strong hydrogen bonding region, some Dutch researchers have done a lot of work on the pure compounds and have figured out where all the different labile protons were. And so there are humulones and lupulones. The humulones are the bittering agents that actually get into the beer. They actually undergo an isomerization when the wort is boiled, when they're present. And these actual compounds you're looking at right here are not water soluble, but when they go through the isomerization to iso alpha acids, they become soluble. We have a HPLC here. Unfortunately, NMR cannot do a good job on the hops once they're in the beer, because you've got water around, all these labile protons are gone, and you're left looking for tiny little hop acid peaks that are there at ppm level, and it's just a mess. But for looking at the raw materials themselves, the NMR does a great job. So we were reporting to these guys on the different alpha acids in detail, and they were really interested in some cases where they'd done it was like 1 year to another comparison of, say, Cascade hops. They were interested in when they froze them versus they just put them into cold storage. Was there a difference in the distribution of the alpha acids? And there really wasn't that much. But you can see a seasonal change that happened here with that product. In this situation, the ASBC, which we should all become members of, this is the American Society of Brewing Chemists. It's like a dream come true for me to be a member of that organization, because I do like my beer. And they actually have standards that they sell for HPLC analysis of hops. And so when we were doing some of these comparisons here, we actually ran that standard to see how well we were doing with respect to total alpha acid numbers and beta acid numbers, because couldn't actually do some of this detailed work because the HPLC method that was developed for these hops doesn't actually see these as 3 different groups. It kind of lumps some of them together. So we're doing pretty damn well there on a QNMR basis. And if you go to 60 megahertz data, those labile protons are out here. You could do that same analysis on these as well. And so I think the benchtop NMRs, there may be a promise for them outside of being sold into junior college just for kind of general NMR introduction. They could actually sit on people's benchtops and actually do analysis of things, but there's going to have to be a mechanism to actually formalize those methods. We've done a lot of work on ciders, and I'm going to keep moving. We do a lot of work where we kind of end up doing sugar analysis of ciders, and at the end we take all the quantitative information that we got and we actually produce full nutrition facts for the beverages that we're looking at. So you can get calories and things like that that the brewers can actually use. I'm going to keep moving a lot.
Yeah.
You can do phosphorus NMR. So we do a lot of phospholipids where you have an internal standard of phosphoric acid, triphenyl phosphate, I'm sorry, and you compare that on a molar basis with the phospholipids you see. We've been looking at chitin in cricket meal by solid state carbon-13 NMR by spiking different amounts of pure chitin into cricket meal and calculating the percentage of chitin that's present in that cricket meal, which was a test that didn't exist in the world until we did it. And our number is magically on the bag. So that's kind of a thrilling thing that you see.
Yeah.
And at the end of the day, I also wanted to, make it plain that QNMR isn't just about low field NMR at 300 megahertz, because Lynette kind of scared me when she started calling 500 megahertz low field. There are lots of low field instruments just doing time domain NMR analysis, and those can be applied to elements. So there is a machine that goes on the back of tractors in Holland that does N14, oxygen 17, P31, and potassium down to in manure spreading. And then there is also a system that was out of San Diego that was doing lithium boron sodium analysis of all kinds of things like salt analysis of snack foods. So QNMR needs to be thought of in a very, very broad area, and we need to bring to bear some groups of NMR people that have a kind of a joint goal to try and come up with standard methods that are out there for people to follow, and that there are mechanisms to, show inter-laboratory comparisons and things like that. Because right now, everybody's in their little silos, either working for a big company doing internal methods, and that's fine, or you're in academia and there's no drive to be doing standard methods. But if we're going to get NMR into general testing arenas, you're going to have to come up with standard methods that people will follow. And I would like to thank you for your time. Sorry I went over a little bit.